Hello everybody. In this video we are going to be looking at the solution to the Physics 1 Hooke's Law Do Right Now 1. Let's take a look at the problem. A spring is laid horizontally on a table and a force of 62 newtons is required to stretch the spring 12 centimeters. The spring is then hung vertically and an object is attached to the end of it, which causes the spring to stretch 9.7 centimeters. What is the mass of the object? Let's take a look at what we're given in the problem. We are given the force applied in the horizontal direction, and that is 62 newtons, and I am using the subscript H here to denote the horizontal direction. I'll use a subscript V to the subscript V to denote the vertical direction. I know my displacement in the horizontal direction is negative 12 centimeters. I'm making it negative because I know that my displacement has to be in the opposite direction of the force. So I made my force positive. I'm going to make my displacement negative. I could have done it the other way around. Wouldn't really change anything, but that's just the way I decided to do that. I do need to convert my displacement to meters, so my horizontal displacement is going to be negative 0.12 meters. My vertical displacement, once the object is attached to the end of the spring, is going to be negative 9.7 centimeters, which is going to convert to negative 0.097 meters. And we are looking for the mass of the object. Now I know when the object is attached to the spring, when it is hung vertically, that the force acting on the spring is going to be equal to the weight of the object. And the weight of the object is equal to the mass times gravitational acceleration. So that's good. I know where I can get the mass from. The bad news is I don't have enough information to solve for the weight of the object in the vertical direction because although I know the displacement, I don't know the spring constant. The good news is I do have enough information in the horizontal direction to be able to solve for the spring constant because I do have the force and the displacement in the horizontal direction. So let's do that. I know that the force of the spring in the horizontal direction is equal to negative k times x. K, the spring constant, x is my displacement. Solving that for spring constant, I have k equals negative force divided by displacement. I'll plug my known values for the horizontal direction into that equation, and I am going to get a spring constant of 517 newtons per meter. Now that I know the spring constant, I can apply that in the vertical direction, and remember that the vertical force is going to be equal to the weight of the object. So the force acting on the spring in the vertical direction is equal to the weight of the object, or the force of gravity acting on the object, which is also equal to the mass times gravitational acceleration. So I can take my Hooke's law formula and replace the force with mg. And doing that, I'm going to have mg equals negative kx. Solving that for mass, I'm going to have mass equals negative kx divided by g. I plug my known values into that equation, and I'm going to get a mass of 5.1 kilograms.